All right, today in algebra, we're going to actually look at then what happens when you have division and negative powers going on. Yesterday, we looked at the first three properties of exponents or powers. We looked at multiplying, a power raised to a power, and then when you have a group of numbers, factors, I should say, being raised to a power, that you can then place that power with each factor. Today we're going to be looking at what happens then when you have a division problem, when you have the same base number. And we're going to be looking at then negative powers as well. Okay, so let's review then. To divide powers that have the same base, what do you do with your powers? If you divide a power that has the same base number, what do you do with their exponents or powers? You subtract them. You find the difference. Now that's providing, again, that your base number isn't 0. So in this case, if I have 3 to the 7th power divided by 3 to the 5th power, my base numbers are the same, so I can just subtract my powers. 7 minus 5 is 2. You get 3 to the 2nd power, or if you wanted to go ahead and simplify that as a whole number, it would be 9. Okay, then if I have a quantity raised to a power, and this is being like a fraction or a quotient, then I can do, like I did with the multiplication, I can distribute it. So I could say this is a to the nth power over b to the nth power. You notice these are not the same base numbers. And that's providing, again, that b is not what number? 0. Good. So this example, if I have 4/5 raised to the 3rd power, that's the same as 4 to the 3rd power over 5 to the 3rd power. And that's a lot easier to figure because you can figure what 4 to the 3rd power is divided by what 5 to the 3rd power is. All right, let's try some. Here I have 10 to the 4th power over 10. Use what you know about the properties of powers to simplify this. What do I do? What will I do here? Okay, it doesn't have a power, does it? So what do you assume is there? Where it's kind of always invisible, right? There's a 1 there. So I have 4 minus 1 gives you 3. So it's 10 to the 3rd power, or you could say that's 1,000. Okay, let's look at this one. Are the base numbers the same? Okay, so I could take the shortcut to my powers, 2 minus 3. So I have 3 to the negative 1. Now, what do we know about negative powers? It goes where? It goes downstairs. It goes under 1. So I have 1 over 3 to the 1st, or I could just have 1 over 3. That's it. I've simplified it. Okay, now let's take a look at this one. 1 over y to the 2nd times y to the 8th. How can this be written? How do you combine them? Because what should... But where is this? Is it on the top or bottom? That's kind of my question. It should be on the top because any whole number, any number you assume then would be over 1. Just like when you work with fractions. So really, what's 1 times y to the 8th? Over y to the 2nd. Okay, now I can apply my rule. And what do I have? Y to the 6th power. I subtract the powers or the exponents. 8 minus 2 is 6. All right, now let's try some others. Let's try to simplify these. Okay, what property we know can happen here? What can I do with each term? Or should each part of this quotient could be raised to what power? So I can rewrite this as 2 to the 4th over x to the 12th. And why do I take it to the 12th? Because it's 3 raised to the 4th power. That's correct. Okay, is this as low as it'll go? Yes, unless you put a whole number there. Are there any negative powers in the bottom? No. Okay, so we don't want negatives down on the denominator, so just make sure that they aren't left there. Now, let me ask you this, because we had this yesterday. Is this a monomial? Why not? Because it could be 0 on the bottom. Okay, and this next one. Let's first, anytime you do order of operations, I can go ahead and simplify the top, and I get z to the what power? That's what you learned from yesterday. Z to the 6 over z to the second. Now I apply the property that we're doing today and subtract your exponents, and I get z to the fourth. Now notice I'm putting a line through that z so you don't think it's a 2. That's just a good habit to get into. All right, let's look at this next one. What will this be? We're raising each part to the second power. 5 to the second power, which is 25, y to the fourth over w to the second. Now, can I simplify anything there? Are these the same? No, they are not. So I'm simplified. Okay, now we're going to try some others to simplify. You want to make sure that you include only positive powers. Only positive powers. Okay, so the first one, it has 5x to the fourth, m to the sixth, divided by 25x to the third, m to the second. Give me a fist of 5. Do you have that written down? Okay, we're good. First look at, is there anything you can do with the whole numbers? Well, I could simplify it like it were a fraction. So if I have a 5 over 25, how could I rewrite that? 1 over 5. And I just always kind of keep my bar, make it big, because I don't know what's going to go on top or on the bottom. So this is 1 over 5. So I know I'm still going to have something down below or in the denominators. Okay, now do we have any like x terms? Okay. Okay, so we have 4 minus 3 gives you x to the first. Now, why does it go up here? Because it's a positive power. Everything always stays upstairs unless it's deemed that it has to go down by a negative power. Okay, so then we'll do our m's. M to the, I subtract my powers, m to the fourth. So to make it a little nicer looking, I'm going to have x, m to the fourth, all over 5. Do I need the 1? No. And then this would be your final answer because I've simplified it. Okay, so I always look first, is there anything I could do with my whole numbers? Yeah, 12 divided by 3 would be 4. Does it go on top or bottom? Top. It's a whole number, so it would be 4. Do I need to put a 1 down here on the bottom? No. I mean, you're kind of used to that. All right, now, these are not in the same order, but let's find them. Your m to the third, and m to the second. So what can you do with your powers? Subtract, and you get m to the first, or just a plain m. Okay, do I have any more x's? All right, now, this was where it gets a little tricky. I have x to the negative third minus x to the negative 4. So I'm thinking in my brain, negative 3 minus a negative 4. Mark, mark, and what do you get? A positive 1. And I'm done with my x's. And then I have my n's. What do I do with my powers? And I get into the, very good, into the second. So do I even need my bar, my division bar, quotient mark? No. So my final answer is 4mx into the second. Okay, number 3, 10m to the second, x to the negative fifth times n to the third, divided by 2 times m to the third, n to the second, x to the negative fifth. Okay, what do I do with my whole numbers? Can I do anything here first? Okay, I get a 5 on the top or bottom? Top. All right, so done with those. What about the m's? 2 minus 3 gives me m to the negative 1, correct? Okay, done with my m's. What about the x's? Okay, you've got negative 5 minus a negative 5, which is 0, so you have an x to the 0. Now, we're going to take care of that in a minute because we know that's equal to what? 1. Okay, and then we'll do our n's. 3 minus 2 is 1. Now, I cannot have any negative powers. What's wrong with this? Okay, the m needs to go where? On the bottom. So I end up with 5 on top, m on the bottom. What about the x? X to the 0 power is just a 1. So do I even need it? Because what's 5 times 1? 5. And so then what's left with the 5? N. So it's 5n all over m. All right, and then our last one, 12 times m to the negative third power times x to the fourth, n to the second, all divided by 4 times n to the fifth, m to the third times x. Let's deal with our whole numbers first. What do I have? A 3. Okay, m's. I have m to the negative third, negative 3 minus 3 gives you, no, negative 3 minus 3 gives you negative 6. Very good. Got to be careful on those. Any other x's? Looks like it. Okay, x to the fourth. This is x to the first. I subtract them, so this would be x to the, I'm sorry, third. X to the third. Good. And then my n's. N to the second and over n to the fifth gives you n to the negative third. Now what do I need to do? I need to do a lot of shuffling, don't I? You have to throw some things down in the basement. What are they? Will the 3 stay where it is? Okay, what about the m? Nope, it goes down. So it's m to the 6th. X stays on top. N down below. That's your final answer. Okay, any questions so far?